Today I'm going to talk to you about the mean and variance of discrete distribution. Okay, so consider the following probability distribution right here. So the probability x equals 0 is 0.2, probability x equals 1 is 0.3, probability x equals 2 is 0.5. We should note that this is a discrete probability distribution because it meets the two requirements of it. The first one is that the probability of each outcome is between 0 and 1. We can see that. The second one is that the sum of the total probability is 1. Okay, so this is a valid probability distribution, and I can calculate the mean of this discrete probability distribution. Okay, so the mean, or the average, is just calculated in this way. So the expected value is x times p of x. Okay, so here the values of x for this distribution are 0, 1, and 2 given above. Okay, and then we also have the corresponding probabilities that are listed. Okay, now the variance here is denoted by these two symbols, and it's given by this formula. Okay. One more thing is that if you work out this formula can be re-expressed in this way: the expected of x squared minus e of x squared, the mean, which is the same as x squared times p of x minus the mean squared. Okay. The last thing is the units of variance are x squared, so the units squared. And so commonly people refer to the standard deviation because it's the unit of the original problem rather than its squared unit, which makes more sense physically. Okay, so let's go through some example calculations of this. So if I want to calculate the expected value, I'm going to do e of x, which is going to be 0 times p of 0. P of 0 is 0.2 right here. The next thing I'm going to do is I'm going to take x equals 1, multiply it by the probability of x equals 1, which is 0.3. Then I'm going to take x equals 2, multiply it by p of x equals 2, which is 1/2. Okay. Then I add all these numbers together, I get 1.3. Now if I want to calculate the variance, it's this formula. Okay, so I'm going to take, we have the value here, that is 1.3. Okay, so mean or expected of x, they mean the same thing. They represent the same thing. The expected value is the mean, and the mean is denoted by this Greek letter. It looks like a U, but it's called mu. Okay. Okay, so I take x equals 0, I subtract 1.3, I square it, I multiply it by the probability of x equals 0. That's 0.2. The next thing that I do is I take x equals 1, I subtract the mean, I square it, I multiply by the probability of x equals 1. I take the next value of x, which is 2, I subtract 1.3, I square it, I multiply by the probability of x equals 2, which is 1/2. Okay. Now I simplify these things, it'll simplify like here. Then finally I'll get these values for each individual term, and my variance will be 0.61. Okay. I'll note that there is an alternate way to calculate this, as we alluded to here. We could have calculated e of x squared, then taken e of x squared and subtracted the mean, which is 1.3, and squared it. Okay, you'll get exactly the same answer. Now the last thing is that if I wanted to calculate the standard deviation, I just take the square root of this. Okay, so the square root of 0.61 will be this 0.78, and that's the standard deviation. Okay, you can also calculate this using Python. It's a lot of code to calculate something that's probably easier done by hand. I just want to show you here that here's x and here's p of x. So x is 0, p of x is 0.2. Now something else that people commonly do is they build this table, which is x times p of x. So 0 times 0.2 gives me 0, 1 times 0.3 gives me 0.3, 2 times 0.5 gives me 0.1. Now you can take x minus mu squared, so this would be 0 minus 1.3 squared. That gives me the 1.69. 1 minus 1.3 squared gives me 0.09. 2 minus 1.3, that's e of x here, gives me this 0.49 when I square it. And then finally I take these values and I multiply it by p of x. And then I can get the same variance using this table, and then I can do the standard deviation. You could also have Python calculate it as well. Okay. Okay, thank you very much.